So let me share the screen. Again, welcome to the Human Interaction course. I am Luigi De Russis, the first name in this slide, and together with me, the course will be held by Tommaso Calò, which is a postdoc here at Politecnico in the Department of Control and Computer Engineer, and we will share the course half and half. I will do more or less the first half part, and Tommaso will do the last half part. So before starting with the actual content, I want to just give you 3 disclaimers so that you are prepared. So like setting the expectation for these 20 hours. The first disclaimer is that especially the initial lecture, like today, tomorrow, and next week, there will be very much conversational. I'm going to ask questions to you, and you are expected to answer to those questions, because otherwise there will be long silence in the room and in the recording. And this is especially true for the lectures. Of course, we will have also exercises, and those will be like conversational, interactive as by definition, because they are exercise. But also for the lecture, we prefer maybe to give a few concepts, a few notions, and have them discussed and understood more than give 30 concepts that you will remember maybe half at the end of the class. So that's the first disclaimer. The second disclaimer is that especially for what concern classes, there is no right or wrong answer. So feel free to come up with, well, there is a right answer, of course. But for what concern your answer to my question, there could be variety. So don't feel free to fail, feel free to give the wrong answer in a way. I will never remember who said what in which date. So that's not a concern for you at all. So again, I will ask questions. You are expected to answer to that question, and feel free to say whatever legit that comes to your mind. And the third disclaimer is that in some parts, especially tomorrow and next week, I will probably exaggerate on something to make a point, and to actually promote discussion and actually promote different opinion. So I expect this. So in some points, in some occasion, I will try to make a point aside much stronger than the thing it is in practice. I've seen from your slides that some of you are very much on one side or another on some topics. So probably my exaggeration isn't really necessary, but anyway, that will happen. Okay, so these are the 3 disclaimers. Any question from now, which is, okay, good. I would have expected something different. The other things I want to say is that we typically do this class in block of 4 hours. This year, they asked us to do blocks of 2. And so some, like today and tomorrow, will be a huge, big conversation about introduction, fundamental, and course logistics, because it was thought as a single class. We always did a single 4-hour class, but this year they said, no, you want to use a classroom, then you have to stay in 2-hour slot. And here we are. So we will probably not finish the introduction today, but we will continue tomorrow. And also why the classes are one day after the other, because they were thought to be in the same half day. Okay. A question, the first question is not really related with the course, but do you know who or what is this picture behind me, this Carter behind me? Star Wars is a series of movie, so maybe.
Whether it's the R2-D2?
Yes, whatever. See, let's forget the name. What's the purpose? It's an android. And?
It's human.
It's an actor.
No, okay, it's an actor, it's fine. Let's not reveal the magic behind the movie. It's an android. It's not an actor, it's not a person inside, it's an android. So in the movie, it's an android that does what? Like, it's human-like.
Serving the owner.
It's serving the owner, but it also has human-like. It talks too much. It listens too little. And then, how it behaves. Yeah, but how it behaves, like it behaves like.
Human-like, but in a weird way.
Human-like, but in a weird way because it's an android and because it's a movie, of course.
It moves in a robot, in a strong.
Yes, in a strong robotic way, but is, you would say, in the movie, but is sort of a intelligent, whatever definition you want to give to intelligence, Carter, in a way? Yes, okay. Good. This was not actually, just to put everybody on the same page, absolutely not relevant with the course, but the questions that are more relevant with the course is, let's start, again, this is a big introduction. So let's start to make a baseline. We are going to talk about human-AI interaction, so how people can interact with an AI system, which is, of course, a subset of how people can interact with computers, with some specific characteristics. We are not going to talk about AI. We're not going to create a new algorithm for improving whatever percentage of performance of that algorithm. We don't care in this course. There are other courses. We are looking at interaction between the two objects, let's say, objects, the human and the AI system, algorithm, whatever. And we may find any of this terminology in the course of the course. And just to see if we are all on the same page again, without going too much into details on this term. These terms are all related with AI. All of them are AI, in some sense. So, question for you. What is classification and what is clustering?
Assigning a label to a specific set of features.
Which one?
Classification.
Classification. And so I have a set of data, and I want to say this is a cat, this is a dog, etc., etc. So I assign the label. And clustering? So sorry, I assign the label so that? Yeah.
You can classify the things.
So that the algorithm can then classify the things and say, oh, this picture of a cat is actually a cat with a certain percentage of success. Is 99% a cat or 90% a cat. Clustering.
Grouping together similar objects.
Is having an algorithm trying to find classes of object on its own without a supervised approach. While classification is supervised, you have to give the algorithm 100 instances of cats and 100 instances of dogs, and then say, okay, this is a cat or a dog, or a chair. And the algorithm will try to guess, more or less. Clustering is not supervised, which means you give a bunch of data, say, okay, see if there are some grouping that some way you are going to come up with. Okay, classification versus regression.
One assigned label, other predicts value.
Yes, and the difference, but also, like, also a label is a value in a sense. So one operates in which the difference is about the kind of data, no?
Yeah,
that
one
you.
is continuous values, one is discrete.
So classification is operate on discrete value, cat, dog, whatever. Regression operates on continuous data, 1, 2, 3, 4, 5 numbers, for instance. Okay, someone else. Unsupervised versus supervised learning. I gave the answer to this when we talk about the classification and clustering. I said the classification was? Okay, so classification is supervised or unsupervised? It's supervised, because I have to say, this is a cat. This 100 pictures are cats. And this 100 pictures are dogs. So I supervise the thing. And unsupervised, there is no human or whatever supervision, because it's more like clustering. Here's a bunch of data. Figure it out. That's unsupervised. Okay, and the first three, if we want to group them in a subcategory of artificial intelligence, we can group them in the label that is machine learning. Then, ontology, which is not machine learning, but still is AI. That's more difficult. Do you have any idea what is? No, not you. Not you. Anyone that knows, except Andrea, what is ontology? Mm-hmm. Yeah, it's a set. An ontology is an artifact for knowledge representation. It's a way to represent knowledge from a very specific angle. It's very much still used in the medical domain, for instance, but it describes and it's logically verified from a mathematical standpoint. It verified that a chair, so in an ontology, in a knowledge representation, you represent knowledge. So you say, okay, a chair is made by 4 legs. And maybe there are chairs with not 4 legs, but also just like this one in the class. And a table is 4 legs and one side, one plane. And the size is typically minimum this and maximum this other. And from this you can infer, giving information in the word. I have something squared, large, 1 kilometer. Is that a table? You can infer, well, no, because a table is maximum 3 meters. And that this is a square of 4 kilometers, and 3 kilometers is not possible to be a table. So it's a way to represent knowledge, represent from the perspective of the user. It's very much binded on maths. But also this is AI. It's not just ChatGPT AI, it's not just machine learning AI, also this is AI. It's the part of knowledge representation. Which is absolutely, in a sense, supervised. There's no learning at all, because actually you describe in a very specific formalism, in a mathematically bound formalism, what is the things you want to describe, and you go on from there. Okay, cold start problem. Now we're going to more specific things. Cold start problem. What is the cold start problem? Have you ever heard? You have experienced the cold start problem. I think all of you, but have you ever heard about it? Maybe more the computer engineer, electric engineer, AI, PhD. Do you have Netflix or similar? No. Do you have a Netflix or Prime Video or whatever? Okay. So.
My system is not trained based on your preferences.
No. It's a problem that happens in a specific moment that is about the start. It's called start. So let's imagine that we create a new Netflix account now. Never had Netflix before. We're going to create an account in this moment. How can the system know that my favorite kind of movies are X? Or that I prefer TV series instead of movies? or can the recommendation system, because Netflix at a certain point say, based on what you watch, you can also like this, this, and that. At the beginning, at day one, how can they do that? Exactly. Some application ask you, and this some application ask you is solving a way to solve the cold start problem. So the cold start problem is, I have typically a recommendation system like the one in Netflix, like the one in Amazon, like customers like you also bought these. This is also a recommender system. But at the beginning, they have no idea what are your preferences. And it's called a cold start because they cannot start the process because they don't have data about you. And so how they minimize the cold start problem, for instance, asking you pick 5 movies so that you can have a start. You can input data into the recommendation. This is a cold start problem, and it's a problem that is very, very specific from recommendation systems in general. And actually, ontology could be also a way to solve a cold start problem, just saying people, this age, this level of instruction, etc., typically knowledge representation. So that's also could be a way to solve the cold start problem. Okay, precision or recall. That's more technical. More again, mostly machine learning.
Metrics to evaluate model's performance.
Say that again.
Metrics to evaluate model performance.
Metrics to evaluate model performance, in particular. Precision.
Well, the recall is the ability to
Okay, the recall.
get the true examples true, to predict true when the example is true. Precision, I don't remember.
Sorry.
The precision is the positive predicted value.
The
Positive predicted value.
positive predicted value. And the recall is the amount of true things you find that are actually true. And in a machine learning system, are they often 100% precise and 100% recall? No, good. That's most of the time they're not. Okay, finally, expert system, which is another kind of AI. It's old AI. 1980 AI.
Based on
Multiple rules.
and based on that they decide which action to take.
Yes, are systems on a specific domain, because they're called expert, but also created by expert that know, in a way similar to knowledge representation in a way. There is a person giving knowledge, and this knowledge, in this case, is put on rules. If I see this kind of data, then these other things will happen. So it's still part of artificial intelligence. Rules could be as complicated as you want. It could be created on the fly, mixed, etc. But still, are a system for solving a very specific case according to some kind of rules. In the simple term, if something happened, then something else happened. Or if an event, then there is a condition which brings one or more actions. And then these actions are part of the system. And this is another kind of AI. And we, in a way, talk about 3 different, or 2.5 different categories of AI system. We talk about machine learning. We talk about knowledge representation. And we talk about expert systems, so rule-based system. Did you know the existence of this kind of AI before today? And what's missing here? Well, if I look at your slide, which I did, I could say that many of you think of AI as deep learning, generative AI, which is a subset of machine learning, which is a subset of deep learning. So we are just shrinking down. We are trying in this course not to focus specifically or only on large language model, generative AI. That is just a tiny bit of things. It's actually popular and used and everybody talks about it. But also we try to think about AI about many other things, not just one thing. So we will try to keep a higher perspective, in a sense, of AI. Because there are many things in common. The fact that you have AI in a system brings consequences, whatever kind of AI is. And then, of course, with generative AI, consequences are very different than with ontology, but still, there are differences. Good. Any questions? So, we talk about AI, and we have a course like this since 2020, more or less, because AI is actually everywhere. Here there are a few examples. Do you recognize them? Or some of them? I think you should. Like, what is this one? Yes. Which is a? It's a voice-based assistant. It could be home or not home, doesn't matter. In this format is like you bought it and you put in your home, and Amazon is happy to get all your data for free. Also having you pay, actually. But still, voice-based assistant also works like on the phone, like Siri, Google Assistant, Bixby, if it still exists, on Samsung, and whatever. Voice-based assistant. You talk with them. In some cases like this, they don't have screens. So you cannot see things. You just have to rely on audio communication. And then similar here, but here you have a screen. This is a system to create machine learning models in a simple way, basic machine learning models in a simple way on macOS. If you want, it's called Create MLL. So also allowing people, not expert people, to create algorithm and machine learning system to use in applications, software application. This one. Is an autonomous driving car, exactly. Yes, by Uber. This is a picture from Pittsburgh, where there is part of Uber totally autonomously driving. So you get one of these, and hopefully you get to your destination in one piece. And this one instead. Yes. Let's generalize it a little bit.
So, an AI algorithm that gives risk rating, risk score grades to some parts of the image, so it gives you segmentation and classification.
Yes, this is a tissue or something. I don't know, of course, what it is. And according to this kind of tissue, it says, okay, this is grade 1, grade 2, grade 3 risk or whatever that a specific mutation, disease, I'm not a doctor in that sense, happen. But also this is AI. So these are very different kind of AI system. We have the simple, in a way, voice-based assistant that most of the time understand you and sometimes don't, to the capability to create some machine learning, to a car that is interacting with the real world, with other cars, with people walking around, bicycles, etc., and indeed as a series of camera, microphone, whatever they need to not kill too many people, and actually a system that is not, let's say, front-facing the real world. I mean, it's not that you find it on the street, but it's a specific tool for doctors, for people expert in a domain that looking at this, they can say something more meaningfully, it's colorful, okay? So very specific use of AI, but actually is everywhere with pros and cons that we know, or we can imagine. And of course, when it works, let's say when it works in quote, it's great typically. No? When we jump on a car like this and we actually go to the destination, we are, well, happy, no? Just no problem. And when we talk what's the weather on the Amazon Eco, and they say it's cold and the temperature is this, we say, okay, it's fine, no big problem. And then, of course, the point is that when it fails, it typically does it not just in a like meh way, like, oh yes, it works, wonderful, nice, but when it fails, it does it spectacularly, typically, or in a very dangerous way, but we will talk about dangerous after. So here there are two examples. Let's start from the second one that now is fixed, but 2 years ago wasn't, and wasn't able with the latest version of ChatGPT to generate something so simple. But what happens here in this chat with ChatGPT that was, I think, ChatGPT 3 or something like that. And there's also something similar also happened in ChatGPT 5.1, so it's not something related to only 2 years ago, but also quite recently. What happens here? I ask what is 3 multiplied 4 plus 9 multiplied 9, give the answer first and then the explanation. And the answer is 87, which is wrong. And the explanation is you have to do 3 multiplied 4 plus 9 multiplied 9, okay, which is 12 plus 81, good. And then the result is 87, which of course is not, because 12 plus 81 doesn't do 87. So what you can notice here, you should notice, well, you can think of one thing at least. Well, it doesn't know how to do the mathematical operation. This is more like inherent in the fact that they're called large language model and like they work on language. And mathematics notation is not exactly a language. So, but the other thing that you can notice is that, or you should notice.
The first part is correct.
In the explanation, yeah, but except for that. If you don't know math, what you would notice? If you don't know that 87 is wrong, what will you think? It's very convincing, it's very sure. The answer is 87, and this is the proof that the answer is 87. So if you are not able to do 12 plus 81, because you are in the elementary school, first year, you say, okay, it's 87, good, and go with it. And I'm writing that 3 multiplied 4 plus 9 multiplied 9 is 87. It's confidently wrong. And yes, there is a small line that says ChatGPT could make errors, double check the results, but it's very tiny and very small in the home page only, which is probably not the best way to convey this information. So according to who is using this could create, well, it's wrong. Let's do a meme on this, or let's open a thread on Reddit mocking ChatGPT, or we can say, okay, it's at 7, let me write it somewhere. And this could happen, this is a very simple case, but this could happen, how do you know that any information given by ChatGPT is actually 100% true? And how much you are relying nowadays on ChatGPT and not thinking that maybe something is not exactly true. So if you have knowledge, you can say, well, listen, no. But if you don't have this knowledge, you blindly believe. And everything is formulated in a way that is not showing doubt. It's not, I think the answer may be 87, but I'm not sure. The answer is 87, full point. 100% precision, 100% certainty in every answer. So this is one thing. And the other thing is the Tesla Smart Summon. That is, let me show you a bit of this video, just a tiny bit. of this video. So you know what is a Tesla, no? Yes. Oh, let me see if the audio goes through the right. No.
So I wanted to show off the Tesla summon feature and actually.
So do you know what is the smart summon of Tesla? So this video 6 years ago, things have changed a little bit, just a little. Do you know what is the smart summon in Tesla? So smart summon is a feature that was just new 6 years ago, so there was a lot of videos, where you basically park your car, go grocery shopping, and since you don't want to cross the parking slot to get your car, you open your app and you call the car. And the car comes to you, so that you don't have to walk. The car comes immediately in front of you. So this person did some experiment in a parking lot, see normal parking lot, nothing really strange in it. And this person is a Tesla, they don't know what it
over
is.
here, there's no one in the car.
Is there?
Let's, see how well it comes through.
Is the white things here? And let's try to call it. Now let's reduce the volume a bit. Through the app.
So we're right here. Go to target. Now you just gotta hold this down and the Tesla's pulling out.
And the car indeed is moving. Slowly, of course. And then and I get confused for it's seeing ghosts probably, and like there is an obstacle there, but actually there is not. And then of course it goes to the wrong side.
Looks like a charm.
And then you stop it and put it in a different place and try it again.
This parking lot, this is probably like my 5th or 6th attempt total. Still have yet to work.
So try again, and well, the car is exiting, and then it's trying to crash on another car. And then luckily it stops, but there is space on the side, so you can like
It's not worth the risk.
pick another direction.
Just for the sake of this video, we gotta try it. We gotta give it at least one more go. Alright, so this is attempt number 5. It's right here. Let's see what it can do. I'm afraid it's gonna think that this is public road.
Now, simple version, just the car is there and here, just came almost straight here. And
Apparently that's where it's supposed to go.
and then
That one might have been up.
just
It's hard to tell
stop.
exactly where you want it to go.
And then continue with other like trial with not particular success actually. So this is part of the like spectacularly, no? Because it doesn't harm anyone apparently, but say fails in a way. And why it fails? Well, ChatGPT, we said, it's a language model, this is math is not language. Not a big excuse, but still, it's not language. It's better with language. Trust me. The Tesla.
I don't know, perhaps the system was not production ready, but...
But was in production, like it was in an actual car sold by, from
they
people.
were in a hurry in order to sell it, and they had to sell it when it was not ready at all. I don't know.
Well, that for sure, but let's, that was not ready to go is absolutely clear.
And
It was in a parking slot, simple parking slot, empty space on the top, and also simple distance to go from there, from here. It's not any particular like strange direction to do. So what could be the
Sensor LiDAR was making things.
assuming the car was working from an hardware and software perspective, and assuming that, well, yes, they probably release it a little bit earlier than they should, but they make it like as a company. 6 years ago, they make a decision to deploy this through a software update to your car, and not a great idea, we have seen, not a great functionality, but of course you are selling a car saying, hey, the car came to you when you called it 100% of time. So good, I'm paying $60,000, $80,000 to get a car that came to me, yay, and no, it doesn't.
It was not trained on a real world scenario.
That's probably, right? That's probably, it's not that engineers in Tesla 6 years ago were totally like dumb. They of course tried the system. They tried the system probably in some parking slot, close to the factories, etc., in some prototype, and iterate on the models, iterate on the things. But how can you be sure 100% to be ready for every real world condition?
You test it in the real world.
But you cannot. You can test every single condition in the real world. Like asphalt is new, is old, there are holes. The sun is frontal to the camera, is on top, is on the back, is night, there is fog, there is rain, there is light rain, there is a lot of rain, there is thunder, there is a storm. You have so many variables. There is a car parked there. There's a car that starts moving parked there. There's a person running in front of you randomly. How can you test all of this? You cannot reliably 100% test all of this because it's impossible. You can deploy it and then collect data after 5 years, and maybe you refine your algorithm and hoping that in the meantime nobody got killed or damaged too much. Just hope, but it's not a reliable way to interpret or to build an AI system. Well, let's deploy it in the world and let's see how many people are killed. And let's try to minimize this number. That's not a good way to proceed, no, in general. But in this case, this feature, there's an AI feature of Tesla, actually didn't work. And it didn't work for years. I don't know if now it works, but it was available for years and didn't work. Pretty badly, actually worked, no? Because it's not that parking slot were particularly strange or something. And so this is on the spectacular because, like, yeah, it's not coming. We can have a laugh that the car is going on the wrong direction, etc. But in the end, again, nobody got killed or something like that. Because likely, like when there was a car in front of it that stopped, probably the system stopped too many times, even when there is nothing. So probably the default was, if you are unsure, stop, which is a safety precaution, but is not, of course, a way to deploy an AI system in an effective way. But there are cases in which AI is actually not just silly, but it's also very problematic. And here we have like two examples. Like, well, on the first one, we have a company, IBM, saying that AI could outthink cancer, or other companies say computer system that read X-ray will make radiologists obsolete. Or when we had the first conversational agent, we said that we reach human parity with conversation, which of course we didn't to the moment yet. And here there is a specific case that system developed in one hospital often flop when deployed in a different facility. Well, there is software discriminate, of course, because it was trained on just some specific data, but also this case is more particular. So there was a system that is also linked in this source. So they deployed a machine to detect some disease, I don't exactly remember what, according to X-ray. So they deployed in an hospital with an X-ray machine for a month. And they said, okay, it works. It's actually find the actual disease on the X-ray that produced. Let's deploy it in another hospital. Same software that worked 90% of the time in an hospital, moved to another hospital, and in the other hospital, it just randomly worked. So totally different performance. 90%, 99% accuracy versus toss a money, toss a coin, and if it's head, then is yes, otherwise is no. So totally random. Same identical software with machine learning. Why? No, in this case, the software worked perfectly. It was not a matter of variations. Well, not entirely a matter of variations, and was more subtle.
Perhaps the system was trained on a specific hospital.
Yeah.
Different testing conditions.
No. It's more subtle than this.
Different people using it?
No, not different people.
Different
All good options, by the way, but
different format of images.
no. In this case, it didn't work because it actually didn't. So in this hospital, environmental condition, testing condition, in a sense, is related. When the doctor, something like this, when the doctor had, in the first hospital, when the doctor has a doubt that could probably be the disease, they will use a different X-ray machine, which put a mark in a corner of the picture, of the frame, than the normal machine for X-ray. So the machine was able to identify the marker in the corner. So since the doctor was saying, if I have doubts, to me, it's probably that condition, I will use that machine because it's more accurate, whatever. They will send the patient there, and the doctors guess it more or less correctly most of the time, and then the machine learning algorithm was trained not to recognize the problem per se in the picture, but learn unsupervised to recognize the marker in the corner of the picture. When they moved to another hospital, the other hospital used different machines. So didn't find a marker, and so just give random results. But if you imagine you are selling this, imagine you are trying to convince doctor, buy this machine, because in this big hospital, it worked very, very well, and then, okay, yes, I will spend $1 million on this, let's buy it for my hospital, and then just give random results. You as a company has a big problem, but also if people rely on it, it's just not, oh, it's nice that Tesla doesn't work, it's actually creating problems because you are interfering with serious health problem of people. So you are misdiagnosing people. So these are, of course, very different problems. But many of them brings to the typical approach in which AI is taught and used and applied in academia and but also in the real world. What is the typical approach of AI in general? No? We have data. Then, what happens? You have images of cats, as we said before. We went to the classifier, if this is a cat or not, is it a dog or not. We have data, and then, which are the other elements? Someone that did machine learning or AI, especially. I mean, not the designers. Mhm.
Subset division, training, validation.
It's in the data. Yeah, you train the model, so you have the model, and then what do you have?
An input by the user.
You have instances, like we want to see, we have a data set of these are cats. We have a model that say, I will understand if this is a cat or not, and then I have instances that say, oh, is this a cat? Is this a cat? Or this is a chair? And then the system produce some output, no? So you have data, the collection of the model of this, the classifier of the data for the classifier of cats, the instances of cats, then you have some AI magic, and then you have the prediction result. No? This is exactly, in a way, what happens in the hospital. So they didn't recognize that the machine learning algorithm, unsupervised, recognize the label, because, oh, precision is good, recall is good. I have matrix, I have models that exist, and this AI magic is a black box that something happened. I give data, I give instances, I come up with prediction results, and something happened. What is missing here?
Explanation of the process.
What is missing here? What is missing in this typical approach? The explanation, we will have a discussion about explanation. It's not that always an explanation is, my opinion, it's not that always an explanation is needed. In some cases, yes. I mean, in other cases, I don't care. Especially then depends which is the explanation. If the explanation is the confusion matrix, we can debate if that is a real explanation for like normal people. But no, it's not that. Evaluation, well, I think that an AI engineer will say, no, there is evaluation. Of course, I tested the model, I divided the evaluation if the results is correct. Yes, but
Human feedback.
yes, who is missing? People. Actually, people there are. Who is providing data? Who is providing data? People. Who is providing instances? Who is choosing the models? Who is evaluating the results? Is all about people. But if you do, how many of you did whatever AI course in your life? Raise your hand. Some of you did. Okay. In these courses, AI courses, whatever they are, how many times they mention the word person, or the topic, or the concept person? Yes, that's the answer I get since 2022. 0. And then we get surprised that, well, actually, the tensor doesn't work, the machine, the X-ray machine doesn't work, and ChatGPT gave confidently random answers. So that's why we also created this course, right? To think about humans interacting with AI. And this is, again, the motivation that you already come up. Most, I don't want to say all, so I say most, but up to now, doing this course, since 2022 here and at Politecnico in Milano, the answer was always 0 when asked this question. So at least in Italy, northern Italy, the answer is mostly 0. Most courses consider user interface or humans as an afterthought near the end, if any, because they focus on the algorithm models. They focus on improving their call. They focus to improve the precision, which are, of course, important, but it's not the full part of the picture if you want to deploy a system for use in the real world. So I was saying before, AI systems are designed by human most of the time. If they are deployed in the real world, is to solve a problem that, by the chance, is framed by human. Again, with human take a specific choice, is evaluated and tested, even in a machine learning perspective by humans, the developers, the engineer, whatever, with an outcome for humans most of the time. The prediction, etc., is not for the machine, but is for human use at a certain point, and presented to humans with a user interface of some sort sometimes. So there is humans everywhere, but they are neglected in all, almost all, most AI courses. So algorithms are not always the answer. We will see in the course that the decision to use or not to use AI is actually a very, very important decision, because maybe it makes sense in some case to use AI, whatever it is, AI, and in other sense, it's just why I should use AI. It just makes no sense. But there is a cost, not a financial cost. There is a cost of using AI. So here there is the example of Netflix, the cold start problem that we told before. And what was the solution that we discussed in Netflix for the cold start problem? Is having a person saying, okay, these are the 5 films that I like. So algorithmic, from an algorithmic perspective, the cold start problem is not solved. There is not an algorithm to solve the cold start problem. The cold start problem is solved by giving an interface to humans so that they can pick some data for the algorithm to use. So a suitable interface is critical to overcome some limitation, even if mostly ignored. But despite this, despite the cold start problem is a classical problem in recommender system, it exists since forever, it's still neglected in most of the AI courses, training, etc. And here there's another example of cold start problem in a way. Okay. Do you know what is this video? If you have an iPhone, you should know. It's face ID configuration. Why this happens? Why the need you to do the scans, etc.? Yes, the system doesn't know your face. Why the system doesn't? Because it missed data, right? And again, this is cold start, how the system can operate without you giving information. It cannot. So Apple came up with this interface, playful, we can say, interface, to make accessible to all users. So move your head slowly to complete the circle, and then you have these green bars that pop up and they say complete or try again, etc. They could have said, well, give me 5 pictures, take some 5 selfies and upload it here. Same results, give pictures, but just in a more complicated way. So also a user interface is critical to overcome and solve some problems that exist that cannot be solved from an algorithmic perspective. So the challenge we want to discuss here is how to ensure that people, in a way, in 20 hours. So it's not really, we will not give a full answer of all this. But how we can ensure that people use AI-powered interface and system with joy and trust, rather with frustration and disappointment. It's high goal. We will just give some hints. Can we design and evaluate AI systems that are more human-centered than the one that we have now that they are not, basically, for most of it? And how can we avoid or minimize problem, failures, ethical issues, etc. in AI systems? So we will try to give you some answers to this, and also some tool to put in practice these answers in the course. And this is a slide that I use in other course, but also fit here, even if it's not about AI, that say that 2 hardest problems in computer science are actually people, and combines convincing computer scientists that people is the hardest problem in computer science. And then off by 1 error because computer scientists and their humor. But actually the other problem in computer science in engineer is people. And we don't do enough of this. Because if you give, again, this is not related to AI, but if you give developers just to do whatever they want, they will come up with these interfaces. So the second one is made on purpose, so let's ignore it. But the first one is actually real. So someone came up one day and say, oh, let's do this thing. And even if you don't know exactly what Vuget is, this is an interface for Vuget, it is a command line tool. You can say, there is a start, there is an add, there is an empty, there is save, load, exit. There are checkboxes in which you can say that you want no info and all info together, because of course you can have no info and all info together. What you have to put here, nobody knows because it's not written. And there is also a pro mode. I don't want to know what is in the pro mode, because this is a simple mode, and then there is a pro mode. So this is just the instinct of a developer, software developer, that doesn't think about people or basic usability in this case. Just had a tool that uses it from the command line and decided to, well, let's not build a user interface on top of it. And so let's pick the 100 option that the command line tool has, and let's put it in one single screen. So we need to, if we can, we need to say, okay, yes, you are able to do this technically. Maybe you can do it better for the people usage. And then maybe technically it's work perfectly, very good. But we can do better. So the scope of the course is actually, as I was saying before, a subset of a larger field that is human-computer interaction, that since actually the beginning of the times were actually considered very close to AI, in which both areas explore the nexus of computing and intelligent behavior. And so we will try to build in this short course upon both disciplines. And as I was saying before, this is a subset of human-computer interaction focusing on AI. So the other question for you is, what's different when we need to interact with an AI system with respect to a computer, a tablet, so an interactive non-AI system? What's different? Why we need to talk about interacting with AI versus interact with whatever technology? Because if they are the same, why bother? Just talk about non-AI, it's easier. And of course there is a difference, because otherwise we won't be here. Now is the time to give also wrong answers.
Perhaps in the first case you can predict the process, and with AI you cannot.
Define predict the process. I didn't say predict the process, you did. What do you mean predict the process?
Yeah, I mean the user made some kind of action, and perhaps the user can is already able to expect something from that kind of process, whatever it is. In case of AI, it's mostly something like I talk with an oracle, and this oracle gives me the answer. I don't know. This is my point of view.
So you're more about the opacity of the process.
Yeah.
Also, most of the time, single input doesn't provide the same output, so it's not very deterministic as
That's the key difference. And because you can have also very complex non-AI system which would like to simulate like an oracle anyway without AI. And so also the process in the case could be not entirely transparent, because maybe it relies on data, or it relies on not because that's AI. It relies on large amount of information inserted manually on deterministic things, and so it's complex. So maybe it's not explainable, it's not visible, it's not transparent by definition, it's because it's hard as a problem. But the key difference is this: if everything works, in a non-AI system, given the same input, you always get the same output. If you click on show slides on PowerPoint, you every time, if it's working, you will have slides full screen. That's it. Whatever operation you do on computer, where there's not AI, given an input, you get an output. With AI system, you don't have this. Think about ChatGPT. If you ask one question to ChatGPT now, and then you ask the same question in 1 month, you will have, with a high probability, a different answer. Maybe not in the content, but in the way in which it's phrased. Take the example as before of the error of ChatGPT. If you ask now that calculation is correct, but it's also written in a different way than 2 years ago when or 1 year ago when I took this screenshot. So even a simple example, when I ask you how much is 4 plus 4, you have a different kind of result. So you are not consistent, reliable in the output. There is always non-deterministic behavior with whatever AI system. Think at Tesla. Tried multiple direction. Even if you try one time, got almost through a car, and the other time it didn't. Even if car was still there in the parking slot. So there is this non-deterministic aspect that is a commonality for the entire system by definition. So how we can move from a process, from a perspective, where when we click a button, something happens, and always happens the same thing until they move the button, they update the software, or they destroy the computer, or something happened, or there is some bugs, to a system where when we press a button, things could happen differently and we don't know. How much, how frequently, how often, when. Think about vocal assistant. Sometimes they get you, sometimes you say the same thing and the answer is, I did not understand. Same input, totally different answer. This is intrinsic of an AI system. So this is where the key difference is. AI-based systems are typically performed under uncertainty, especially in machine learning. You have false positive, you have false negatives, and they can also be incorrect. And then also they can demonstrate behavior that are not only unpredictable because they are based on uncertainty, but they can also be disruptive, confusing, offensive, and dangerous. Which non-AI systems typically don't have this full set of characteristics, if not done on purpose at least. Because they are instead based on certainty, they're based on deterministic behavior in any case. So what's different, again, in interactive AI system is that before designing a system, we should ask, or any system that use AI, we should ask what problem should be solved. So does it make sense to have AI here or not? Yes, it's fancy to have AI everywhere, but does it need to have AI here? And which AI approach match human expectation given the problem? Because we have seen there are many, many areas of AI. It's not just GPT system and similar. And which problem can be solved well enough for a particular use case. Because in that big problem, maybe there are things that is easier to solve with AI and other things that is actually not yet possible to solve it. So let me stop here, actually. We will continue tomorrow. Of course, we are going to, well, this is a PhD course, also because human interaction is interesting research. Explainable AI is one area, human-centered AI, all the medicine areas embracing AI as well are part of this. And this course will give you some starting point direction, research-based, so that if you want, you can also go deep on different topics and also general principles and idea that apply across the board. So you can also have some direct usage of this. But before, we will continue tomorrow with this set of slides that is like fundamentals and course logistics. What I want to do now is give you one news and then do the madness session because you did the slide. So it's time to, I use the slides. tomorrow we will see how I use your slide, and that's also why I asked you by Sunday. But we are going to do now the madness session because at a certain point, tomorrow you will discover that you will need to form groups. So knowing you for a second, your interests could also be helpful to the groups tomorrow onwards, group of 3-4 people, or 3-5 people, I don't remember. But more or less this size. The news is that tomorrow we will start half an hour later. So we will start 2:30 and we will try to end at, whatever it is, 4:30, 16:30. So we would just shift the starting at 2:30, and so we would do 1 hour and a half tomorrow until the end. Today we started a little bit later, and we'll try to finish a little bit early, so more or less the same time of usage. So let me stop this.